Is this a good statistical question? Why or why not? An election committee wants to know how voters in its area will vote in an upcoming election. They call 150 voters by selecting every fifth name in a telephone directory. In order for a question to be a good statistical question, it has to have no bias, it has to have a random sampling, and it has to anticipate variability. So in this case, yes, it's a good statistical question because it is random. It's asking 150 voters. They're selecting every fifth voter from the telephone directory. It anticipates variability, so they're calling on different people to get different answers. And it is not biased because they are looking at just randomly selecting these voters from the telephone directory for the area. Is this a good statistical question? Why or why not? An airline wants to know how many flights an average business person takes each year. The airline surveys 150 people waiting for their luggage at an airport carousel. Although they select 150 people, which is a good amount of a good sampling of people, this is not a good statistical question because not all the people picking up their luggage are business people, which would then lead to some bias. Now we need to make the following situation into a good statistical question. A school principal wants to know if eighth grade students would prefer an end of the year dance or a class trip. An example of this would be to have the principal survey every fifth eighth grader walking into the building to see if they would want a dance or a class trip. So here you are surveying the population of eighth graders because they're the ones that are going to have the trip. Every fifth eighth grader walking into the school would give a nice random sampling, and we're asking them the question if they would prefer a dance or a class trip. So it's random, it anticipates variability, and it's a good sampling of the population. When using the measures of center, each measure of center tells you something different. The mean tells you that if everybody were to get the same amount, that amount would be the amount they would receive, or per person, or per hour, that type of thing. The median tells you 50% of the data is on one side and 50% of the data is on the other when ordered from least to greatest. The mode tells you what occurs the most, and the range shows us the spread of the data by taking the high minus the low. So in order to start this problem, we're going to go ahead and put them in order from least to greatest. So we have 72, 73, 74, 75, and 76. In order to find the mean, I would add all of these values together, and I would divide by how many data values I have. So I have 1, 2, 3, 4, 5. When I do that, I get 370 divided by 5, which equals 74. So if everybody scored the same, let's say these were test scores, the score would be 74. In order for me to find the median, I start crossing off small to large, and the one left in the middle is my median. So 74 is also my median. And you can double check this by seeing that there are two data values to the right of the median, two data values to the left of the median. As I look through my data set, 72, 73, 74, 75, 76, there is no mode. We don't use 0 as a value, 0 because it does have a value. And when I look for my range, I'm taking the high minus the low. So since they're already in nice order, I'm going to take 76 minus 72 to get a range of 4, which is small variability. Again, we're finding the mean, median, mode, and range. So I'm going to go ahead and put these in order from least to greatest because I'll need that anyway. 5, 5, 7, 9, 9, 9, 10, and 10. In order for me to find the mean, I would add together the data values. And I divide by how many I have. 1, 2, 3, 4, 5, 6, 7, 8. So I'm dividing by 8. So for my mean, my number sentence is 64 divided by 8 equals 8. That's the value of my mean, which means if everybody had the same amount of whatever this would be, it would be 8. Again, and you can see that it looks like it could be in the center of our data, 8. For the median, that's the middle set, where 50% is on one side and 50 is on the other side. So we cross off, small, large, in pairs, we cross off. And I have 2 medians left over. We can't have 2 medians. So I can do one of 2 things. I can recognize that 9 is the median because there's no number in between 9 and 9. Or I could add together and divide by 2. 9 plus 9 is 18, divided by 2 is 9. So we still get a median of 9. I can also see that there are 1, 2, 3 data values this way, 1, 2, 3 data values that way, or 4, including those 2 9s. The mode is the one that occurs the most. And the mode in this case would be 9, because there's 3 9s, there's only 2 5s, and there's 2 10s. So 9 occurs the most. And then, of course, the range is the high minus the low. So I would take 10 minus 5 to get 5 for a small spread of data. There are 5 whole numbers in a data set. The mean of the data set is 10. The median and mode are both 9. The range is 7. The greatest number is 14. What are the numbers in the data set? So I need 5 numbers to help support my answer. So 1, 2, 3, 4, 5. It told me the greatest number was 14 and that the range was 7. So that means the high minus the low has to be 7. So the only number that can be here is 7, because 14 minus 7 is 7. They tell me that the mode and the median are 9, so I know that this middle number has to be 9. And since it's a mode of 9, this number is going to be 9. So now what I have to do is I have to figure out to get a mean of 10. So what I'm going to do is I'm going to add together 7 plus 9 plus 9 plus 14 plus x has to equal 10 when I divide it by 1, 2, 3, 4, 5 numbers. So in order to simplify my expression, I'm going to add all of these up. I get 39 plus x equals 10. I have to take these values and divide them by 5. So at this point in time, I can't do anything with the top part because 39 plus x is divided by 5 to get to 10. So in order to get rid of it, I'm going to multiply by 5 on both sides. So I've got these cancel out, which becomes 39 plus x equals 50. And then I solve it like an equation. I subtract 39 from both sides. So x has to equal 11. And so 11 is my missing data value. Here's a line plot that you could set up for showing the distribution of data for people that were attending the mall and their ages. And as you can see, I went and I skip counted by 5s all the way up. Now I didn't put the little numbers in there because it's difficult to read, but if I had some more space, I could write that this was an 11. That would make sense. And this was 18. However you wanted to write, or 17, 18, and 19 in here. But by doing intervals of 10, I can kind of see what's on the inside. So when I take a look at this distribution, if I wanted to kind of draw it out, it would look something like this. Okay, so in this case, it definitely is a little bit more right skewed. Okay. And when I look at the center, if I use the median, which would be very easy, I would cross off all the x's until I got to the middle set of data, which was 35 is the center. And that makes kind of sense that this would look like just about the center of our data, where 50% of the data is on one side, 50% of the data is on the other side. And then we would also call this a large spread. So as I'm looking at this and I'm trying to decide why would this be right skewed, I could possibly say that this is kind of the teenage years here up through the early 20s are kind of the people that do go shopping at the mall. Whereas when you start to get to 35 and older, these people might be working full time. There probably are less people there. So there are just some inferences that you can make about the 25 shoppers at the mall. Okay, 15 people were asked to state the number of hours they exercised in a 7-day period. The results of the survey are listed below. So first I made the frequency table, and in my frequency table you can see here that I have set up with the hours, the tallies, and the frequencies. I started by looking at the large number and the small number. So when I found the the small number was 2, and my largest amount was 13, I knew I had to make sure that I incorporated those two numbers in my frequency table. So I started by counting, skip counting with 2. So I did 0, 1, 2. Then I went up 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And every time that I saw a number fall within these categories, I make a tally mark. Even a number like 6.5, I know 6.5 goes in between 6 and 8. So then I show the frequency of how often it happens. The hours are my x-axis and my frequency is my y-axis. So you can see here I labeled hours and I labeled the number of times or the frequency. When I looked here, I saw that I needed to make a 0 to 2 bar, a 3 to 5, 6 to 8, 9 to 11, and 12 to 14. And then as I looked on my y, I saw that my low number was 1 and my high number was 5, so I decided to count up by 5 starting with 0. Remember that there has to be space in between the y-axis and the first bar because this 0 belongs with the y-axis. This 0 belongs with this bar. So then I represented the histogram by connecting the bars because these intervals are connected. What can I tell from here? I can tell that people exercise in a 7-day period the most 6 to 11 hours because they're both exactly the same. How many people did that? 10 people exercise from 6 to 11 hours. I can also tell that this data is a little left skewed, which means more of the data is on the right side, so it's left skewed, which means that people do exercise a little bit more. I can tell that the center is at between 6 and 8 hours. That would be kind of like I'd be using the median or the mode, kind of right in here between 6 and 8 hours. And I can say that there is a large spread. A high school principal made the frequency table below showing the number of students who were late to school over a 5-day period. So we want to use this table over here to answer some questions. So they're asking what is the range of the data. So in order for me to find the range, I have to find the largest amount, which is 22, and the smallest amount, which is 7. And I take 22 minus 7, which gives me a large spread of data, which means there's a lot of variability in my data. In order for me to find the median, I have to take the numbers and I have to put them in order from least to greatest. So I start with 7, 10, 12, 18, and 22. And I cross off, in pairs, small to large. The middle number, where 50% of the data is on one side and 50% of the data is on the other side, is 12. The mean is going to add up all of these data values. So 7 plus 10 plus 12 plus 18 plus 22, and I'm going to divide by the 5 days in the week. And when I do that, I get 69 divided by 5, which is equal to 13.8. So you can see there's a little bit of a discrepancy between my median and my mean. My mean means if everybody missed the same amount of we're late the same amount of days, it would be 13.8 days. Okay, so what trend is apparent? We know that 7 kind of is an outlier. Okay, and what's happening with this 7 is it's taking my median, and 22 also could be considered an outlier because it's kind of dragged it up here, but 7 and possibly 22 are outliers which are affecting the difference between the median and the mean. So this is why we have a little bit of a discrepancy here, because we do have an outlier. It says in his first 3 rounds of golf, John scored 72, 78, and 73. What is the highest score he can earn in his 4th round and still have a mean of score of no greater than 74? So they already gave us what the mean equals. So we have it equals 74. And we know there's a missing value because we want to know what he can do in the 4th round. So what we have to do is we have to set it up like an equation. So 72 plus 78 plus 73 plus this x value. When I divide that by all 4 rounds, we want him to get to 74. So the first thing I'm going to do is combine these like terms. And when I do that, I get 223 plus x divided by 4 has to equal 74. So now I have an equation that I can recognize and solve. So what this is saying is 223 plus some value, when I divide it by 4 is going to give me 74. So in order for me to solve this, I have to multiply by 4 on both sides to get rid of that divide by 4. So when I do that, my problem becomes 223 plus x equals 296. So now I have a one-step problem that I can solve. I subtract 223 from both sides. These cancel out. So x is going to equal 73. If I put it back in here and I added all 4 values together and divided by 4, it would equal 74. So he needs a score of 74. That would be your final answer. Okay, we're going to design a box and whisker plot for this data set. And so what I did initially is I went ahead and I put all my numbers in order. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers, checking to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So I have the data set marked on here. So the very first thing that I did is I made my number line. I saw that my small number was 11 and my large number was 18. So that's kind of a small spread of data. So I went ahead and represented all the numbers on the number line. And notice that even though I don't have a 17 in my data, because this is a number line, it has to be on there. So I went 11, 12, 13, 14, 15, 16, 17, and 18. So the very first thing I'm going to do is I'm going to go ahead and find the median. So I find the median by kind of crossing off small to large, small to large. I'm just making little marks in here, small, large, small, large, small, large, small. So my middle number here is 13. So as you recall from class, we would mark this with a vertical line. Additionally, I'm going to take my 11 and I'm going to put a dot on my 11 and I'm going to put a dot on my 18 because those are my minimum and my maximum values. So I have that, those are like my stopping points. And then here's my median represented. From here then, I take a look and I think about what the median means. Median means that 50% of the data is on one side, 50 is on the other side. So if I don't include 13, I have 1, 2, 3, 4 numbers on that side, 1, 2, 3, 4 numbers on that side. So this is my middle part of my data and I'm not going to use it. These numbers over here are numbers for my lower quartile and these numbers are for my upper quartile. And in order for me to find the lower quartile, I have to find the median of the lower 50%. So I cross off and I have 2 12s left over. I can only have one number for a median, so 12 plus 12 is 24, divided by 2 is 12. So my lower quartile number is 12, and I mark that with a vertical line. I do the same for the upper quartile. I cross off, and I look and I see that I have 14 and 16 together. So I say, well, what's in between 14 and 16? That would be 15. Or if I added about 14 plus 16 is 30. 30 divided by 2 is 15. So I'm going to go ahead and put a vertical line on my upper quartile, which is my upper 25%. And then I go ahead and I find my box by boxing it in. And I draw my whiskers out to the line. And I have my box plot represented. So our median in this case, which is this, these are our this is part of our 5-number summary, is 13. My lower quartile was 12. My upper quartile, forgot to write that in, is 15. The range is the minimum and the maximum value. So it's 18 minus 11, which is 7. And it asks how many people were represented in the survey. And I counted up the data values, and there were 9. Okay, in order for us to find the mean absolute deviation of Sherry's gift registry, we first have to find the mean. So what I'm going to do is I'm going to add together all of the data values. And when I do that, I get 328 divided by 6. And I get a repeating decimal of 54.66666. So in order to make this easier for myself, we're going to go ahead and say that the mean gift value is $55. Okay, so that means if everybody bought Sherry the same price gift, it would be $55. So that 55 falls right about here on my line plot. So I already created a line plot just so I could see the data values. The next thing I have to do is I have to find all of the differences from the mean to the data values. So I'm going to start with the left side, and I do 55 minus 15, and that equals 40. So I'm going to be using this number of 40. Then I do 55 minus 22, and I get 33. So I'll be using that number. Then I have to do 55 minus 29, and I get 26, and I'm going to use that number. And so as you can see, I'm doing every data value over here. Now I'm at 55. I don't have to do 55 minus 55 because there is no, 55 was not a number that was purchased from the registry gift. So now what would happen is I would do 55 minus 58, and I would get -3, and I would have to use the absolute value. But remember, we talked in class, so we're going to just go ahead and switch that around to 58 minus 55 and get our positive numbers. So we're going to need 3. That one's really close to our mean. Then we're going to do 75 minus 55, and we're going to get 20, and we have that value. And then we're going to have 129 minus 55, which is going to give me 74. Okay, so now I have, one, found the mean, which was $55. Now I found the difference from the mean. So now I'm going to take those differences, so 40 plus 33 plus 26 plus 3 plus 20 plus 74, and I'm going to divide all of that by the 6 data values that are there, 1, 2, 3, 4, 5, 6, and I'm going to get my mean absolute deviation to equal 32.6 repeating, so we'll call it $33. So basically what that's saying is that 33, because it's above 5, remember anything from 0 to 5 says there's very little variability in our data. This 33 says there's a lot of variability in data. And the reason would be this, is that when people buy things off a registry item, they buy what they can afford. So not everybody buys the same price thing. So we would expect to see a large variability in this data, and that is what we found out. In order to answer this question, it says family A and family B both have 8 people in their family. The ages of each member is listed below. Which statement is correct about the variability of the 2 families? And before we try to take a look at variability, there is one way that you can do it, and you can take a look at the range of the data. So if I look at family A, or the spread of the data, excuse me, which is also the range. Family A, the oldest person is 42, and the youngest person is 3. So 42 minus 3 equals 39. That's the range or the spread of the variability, spread of the data, which also talks about variability. When I take a look at family B, the oldest person is 35 and the youngest person is 1. So we have 35 minus 1 equals 34, excuse me. Okay, so we do see a little bit more variability in family A than family B. But as I look through my selections here, it doesn't talk to me about just the spread of the data. It is actually talking to me about mean absolute deviation. So I have to calculate out the mean. So family A, call them family A here, and family B, when I calculate out the mean and I add them all up, this one becomes, 130 divided by 8, which gives me about 16.25. And for family B, I get 95 divided by 8, which is equivalent to 11.875. So in order to make things a little bit easier, I'm going to round this one down to 16 I'm going to use as my value, and I'm going to use 12 here. So again, we're still seeing family A with slightly more, if everybody was the same age, it would be 16. If everybody in family B were the same age, they would be 12. Okay, so there's a little bit of difference there. Then when I go to calculate out the mean absolute deviation, okay, which is definitely going to show me the variability, like how far everything is from the mean, so we're looking at that variability. When I calculate that out and I find the differences and I add them up, I get 88 divided by 8. Makes my variability an 11. When I look at the mean absolute deviation for family B and I add them up, all the differences, I find the difference from the mean to each of their values. I get 81 divided by 8, and I get 10.125. So very, very close in variability. I would not have expected that to happen. So I look at, and since I rounded, this could very well be the same mean if I had used regular numbers. So I would give you A as a possible answer. I would also give you B. The variability for family A is greater because the mean is greater. Well, no, actually that wouldn't work because mean doesn't show variability. So the correct answer here would be the variability is the same for both family A and family B because they have the same mean absolute deviation. In this case here, when I'm looking at variability, variability does not go with mean. That's why it cannot be B. So letter A would be your correct answer. In a data set, explain when you would use the median rather than mean when there is an outlier. So for example, you did very well on all your tests, and pretty much you scored the same, and then when you got to you accidentally did very poorly on a test, all of a sudden that mean is going to drag your measure of center down. So we would want to use the mean or the median when there is an outlier because that gets crossed off first. In a data set, when would we want to use the mean rather than the median? When all of the data values are close to being the same. Again, if there's an outlier, we wouldn't want to use that. If we have similar data value, we would use the mean. So when there's no outliers as well is when we would want to use the mean rather than the median. In a data set, explain when you would use the mode over mean and median. You would use the mode when data centers around one value. That's when you would want to use the mode. So you get 90, 90, 90, 90, 90, 90, 90 on every test, and maybe then you get a low data value. You would want to use that 90 as your measure of center. What does the mean absolute deviation say about the variability in the data? Well, a small mean absolute deviation, like less than 5, means little variability or more consistent data. A large MAD, meaning greater than 5, means large variability or less consistent.